Hello students. After taking rest, we are ready to continue our session today. And okay, I changed some of my slides in the time you are taking rest, and so I again uploaded the PDF file. That is why I said to you that you must wait until I finish this chapter, and then I can upload it to درسا to give you this PDF file. So where were us? Yes, this slide. Did you think about the answer of this question? As I said we had two main advancements in 80 decades. Okay, the first one was about powerful microprocessors and making computers smaller and cheaper. And I asked you about the second one. I asked you and I wanted you to guess it. Yes, exactly. As Mr. Hadi Mustafa said, the second development was the invention of high-speed computer networks. It's about network of computing machines. It appeared in mid-80 decade too. But what is network or computer network? Let me zoom it. First of all, I want to ask you, how much are you familiar with computer networks? Or have you passed computer networks course? There's no picture, but I can see the picture. Is the picture shown for you? Your friends can see the picture, so it may be your fault, or your system fault, or your connection speed. So I was speaking about network of computers or computer networks. I asked you, how much are you familiar with computer networks, or have you passed computer networks course? Have you had this course? What's your major? You are software student or hardware student? I mean your bachelor. all of you was software student in bachelor? I asked you about your major in bachelor, okay? Software or hardware? What about other students? There are 18 students in the class, but only 3 or 4 students are typing and attending and answering me. Computer engineering has 2 majors, hardware, software, IT. So some of you are software and some students studied hardware. Okay. But now in master degree, I suppose all of you are studying in software engineering, aren't you? Okay, no problem. Good. Those students who studied hardware engineering in bachelor completely are familiar with computer networks. But don't worry about the concept of computer networks. This course is not titled for computer networks. It's about distributed systems. Although distributed systems is very connected with computer networks. This picture is a LAN or local area network. As you can see, we have different computers here connected to each other using a network. The rate of data transmission in LANs is usually between 10 to 100 megabits per second. This data transmission is about LAN, local area network. So it depends on many things. It depends on the cable we use, computers together, switches, and also the servers, and also the traffic in the network. But it should not be lower than 10 megabits per second. If the rate of data transmission in a LAN would be lower than 10 megabits per second, there would be a problem. Local area networks allow us to connect many computers. What I mean by many is really many computers, 100, 200 computers, or even more. Hundreds of computers in one building. Please pay attention, in one building to be connected. And the data transmission, I talked about it, and we have different methods to connect computers. We can use cables, or we can use wireless network to connect computers together. The another network that we can use is, what is it? The another network except LAN. Yes. WLAN or WAN. We also have WAN except of WLAN. I mean exactly. Yes, WAN. WAN stands for what? Quickly reply, please. WAN stands for large network. Okay, the meaning is near, but exactly wide area network. WAN stands for wide area network. And as the name implies, our network is very, very wider than LAN. LAN is local area network for a building, computers in a building. But WAN is wide area network. For example, between some machines located in different cities, in different countries even. It is called WAN. The wide area network usually allow thousands or even millions of computers to connect to each other all over the world. Can you give me a good example about WAN? Who can give me a good example of WAN? Very good, very good, very good. Internet. Internet is a very, very good example of WAN. You can connect different machines all over the world together by using internet. So internet is a type of network called WAN, wide area network. Are we using WAN now? At the moment, we are using e-learning here, okay, with Adobe Acrobat, Adobe Connect application to teach and listen this course. Can we say that we use WAN? Of course, yes. Of course, yes, because we are communicate and transfer data and information by using internet. So it's WAN. Good. Now, before I back to the previous slide about the definition of distributed system, I want to ask you another question. But first, I want to say that the result of these two technologies, I mean microprocessors and computer networks, these two technologies resulted into make easily computers connect together and have a distributed system. But let me back to previous slide. Yeah. Look at this picture. You can see different machines, each of which has a powerful microprocessor, and they have connected together as a network. This is usually called distributed systems. I mean, it is in contrast to centralized systems. What is centralized systems? I'm sure that you know what is centralized system. The other name of centralized system is single processor system. No, it's not server always. Centralized system or single processor system is a system that uses only one processor. Only one processor. So if a server has multiprocessor system, it is not called centralized system. Centralized system is a single processor system. Why we call them single processor system? Because it uses only one processor, as I said. On the other hand, in a distributed system, the system contains two or more processors. For example, in this picture, how many processors exist? How many processors do you see? Five processors, four processors, four or five. Who can say the exact answer? The exact answer. One single? No, of course not. You can see some computers here. How can you see one single processor here? Coherent. The system must be seen as a coherent system, okay, for a user. It's okay, I know. But how many processors are there in this picture? How many processors can you see in this picture? How many? Give me a number. Some students said 4, some others said 5, but it's not the exact answer. Be careful and think carefully, think deeply. In this picture, we see 4 computers and 1 server, each of which has at least one processor. I repeat again, each of which has at least one processor. So we will have at least 5 processors in the picture. The phrase at least is very important. It's very important. Each device is a machine, and each machine has at least one processor here. Okay? 4 computers, each of which has at least one processor. The server also has at least one processor. So at least 5 processors. We don't know exactly how many processors the server has. 1, 2, 3, 4, 5. We don't know. but at least one processor must be. Yes. Each machine can become processor in the coherent system. Did you get the point? No. Maybe 2 or 3 or 4. No. At least 5 processors. We have at least 5 processors. I mean 5 processors or 6 or 7 or so on. Yeah, maybe more. But at least 5 processors must be, because each machine needs a processor. So, do you think we have all the necessary things to make a distributed system? Some different machines, they are independent, and we connected them by a network. So, do you think we have all the necessary things to make a distributed system? Again, look at the picture. We have some different machines. Each machine is independent. We connected them together by a network. And I asked you if it is all the thing, if we have all the necessary things to make a distributed system. Should be yes. Please participate. I invite all the students to participate in the class, to participate in discussion, to reply the answer to my questions. Don't worry about your answers. It is okay if you don't know the true answer, the right answer. But please type something. Please attend, participate in the class. I repeat my question. I repeat the question. Here we have some computer machines. They are independent, and we connected them by a network. So, do you think we have all the necessary things to make a distributed system here? Is there anything else that we need? Is there anything else that we didn't speak about it? If yes, why? And if no, why? What do you mean by middleware? What do you mean by middleware? No. No. It's not the answer I'm looking for. No, don't talk about removing server or computers, okay? Please pay attention to this picture again. Pay your attention, look at the picture. I said we have some computers, they are independent, and we connected them to each other by a network. The question is that, is the all necessary thing to make a distributed system? Is it all the things? I mean, is there anything else that we didn't talk about it, but it's very important to have a distributed system? If yes, so what is it? Yes, exactly. Yes, exactly. This is the answer I was looking for. This is the example I was looking for. Having a network of powerful microprocessor systems is not enough to make a distributed system. The answer to this question is no. So, I would refer you to the other thing except hardware. We talked about hardware, for example, computer systems, independent machines, microprocessors, network, okay? This is hardware. But what about software? We need a software, we need a specific software to manage this network, to manage this system, okay? But we didn't talk about software. It's very important. It's very, very important. Please do not pay attention only to hardware. The hardware does not work without a software. It's a principle in computing machines. No hardware can work without a software. We always need software. So the software is also an important thing. The software is also as important as the hardware. Do you agree? Do you agree with me? Well, very good. Very good. The point I want to add to my previous explanation is that in contrast to single processor systems, distributed systems need a different software to manage all the system, including the network and handling machines. For example, as you can see in this picture, we have some computers. I said they are independent. For example, one computer uses IBM operating system. The other is a laptop using, for example, Microsoft. The other is a system or machine that uses Apple Macintosh operating system. Okay? It is the meaning of independency. They are independent. They use its specific software or operating system. But in the distributed system, in the whole system, we need a different software to manage all the system, a different operating system. It is called distributed operating system. It's the phrase, it's the very important phrase, distributed operating system. In other words, we need a different operating system for distributed systems. And in this course, I try to talk about different aspects of such an operating system. I try to talk about different aspects of such an operating system. Got it? Clear? I try to slowly speak about important phrases and sentences, so it would be easy for you to understand it. Okay, very good, very good. Now we can go to the next slide now. Like a computer between these systems, when we use computer, it means we use a hardware and software together, okay? No, I exactly spoke about a software called distributed operating system. This software, of course, must installed on hardware to be run, okay? But the important thing is the operating system, the distributed operating system, to manage, to handle these machines and the network, to have this distributed system. Usually this operating system is installed on a server. For example, Windows Server is an operating system for managing distributed system. It is called Windows Server. It's a different operating system. We use home version of Microsoft operating system. But if we have a distributed system, we need a distributed operating system such as Microsoft Server operating system. Microsoft Server Windows. You heard about it. I'm sure you heard about it. Is it okay? Can I go to the next slide? Okay. And now, let me back to the previous slide about the definition of distributed system. We had this slide before. This definition, as I said, has two main aspects. But firstly, let me to repeat the definition. A distributed system is a collection of independent computers that appears to its users as a single coherent system. A collection of independent computers that appears to its users as a single coherent system. It means, in fact, we have different computers, each of which is located in different city, different location. But the user must see this system as a one single system. The problem is how. What should we do to this system that users see this system as a single coherent system? It is the main job. It is the main job. This definition has two main aspects. The first aspect deals with hardware. We talked about hardware. Completely we talked about the hardware, okay? The machines are autonomous. What is autonomous? Do you know what is autonomous? What does mean autonomous? I will type it here. Autonomous. What does it mean? Autonomous. Automatic? No, not at all. It's not related to automatic. It is mean a machine can cope with any system. Computers that work together to give the appearance of a single coherent system. Each machine has its operating system and memory. It's better. It's better. Let me give you an example. It is something related to independency. Autonomous is something related to independency. Independency means istiqlal. You know what is istiqlal? It's an Arabic word. Independency, istiqlal. So, autonomous is also something related to independency. To give you a good example, think about your country. I'm talking about Iraq, your country. Good. I found a good example. In your country, Iraq, Kurdistan claims as an autonomous. Kurdistan claims as an autonomous. In other words, Kurdistan has its government, parliament, and they have their rules. It is the meaning of autonomous. Got it? I was talking about the meaning of autonomous. Yes, it's related to independency. Independent. Exactly. Yeah, something like that. So, what was I saying? Yeah, I was saying that the definition has two main aspects. The first aspect deals with hardware and machines are autonomous. It means machines are completely independent. So in distributed systems, machines should be autonomous, and it means each machine has its operating system, its file system, and its applications. This is the meaning of independency and autonomous. And the second concept, what is it? It deals with software. Users must think and must see that they are working with a single system. And they must not notice that the system is distributed in different locations. Yes, exactly. Computer 1 works on Windows and Computer 2 works on Mac OS. Yeah. Now, examples of a distributed system. The first example is about a network of workstation in university. A network of workstation in university. In this workstation, in addition to users' personal workstation, there might be a pool of processors. It means we have many processors in the machine room. Machine room is something like servers, for example. We have some servers with many processors. The processors are not assigned to specific users, but they are allocated dynamically as needed. I mean, they are idle, and if we need them, we can allocate them to users or students. We have some idle processors, and when we have a request from a user, so we can allocate one of the processors to the user. Such system might have a single file system with all files accessible from all machines in the same way. For example, all the systems suppose that uses Microsoft operating systems. So the file system is similar. File system, what is file system? What do you know about file system? What is it? Exactly, file system such as like FAT or NTFS or Unix file system or Mac file system and so on. The way we use to store and read files, it is the file system, to store files on the disk and read them. Well, so in such a system, in this system, I mean workstation in a university, when a user requests to execute a command, the system could look for the best place to execute that command. You are a request, you want to execute your command, and the system looks for the best place to execute the command. Maybe the best place is your local machine, is your computer, your PC, or possibly an idle processor in the processing room. We had some idle processors, and we could assign and allocate some of them to the user to execute their commands. So it is the system duty, the duty of system. Who can run this policy? I mean, this duty is on whom? In the distributed system, I said it is possibly to look for to find the best place to execute user commands. Maybe the system decides to execute the command on user's local system, or to allocate an idle processor to execute the user command. So where this policy is being run? Exactly in the operating system, or to be more precisely, distributed operating system. The distributed operating system decides about these policies. This is the software that I said we need it to have a distributed system. So the second example about online banking. It's also a distributed system. Why? Why online banking could be assumed as a distributed system? Why online banking can be assumed as a distributed system? It may be your exam question. So please think about this question, because it looks to the user as a coherent system. Yeah, and also to more of users. The answer is simple. What was the distributed system? Let me back to this slide. What was the distributed system? I said a collection of independent computers that appears to its users as a single coherent system. If a system satisfies these two concepts, so it could be a distributed system. And online banking satisfies these two concepts. There are many independent clients in Baghdad, in Mashhad, in Los Angeles, and all of them can use online banking, can use internet services of a specific bank. Okay, so they are distributed in different locations. Also, all of them see the system as a single coherent system. When you use online banking, how can you see the system? For example, you are going to internet and you want to transfer money from between your accounts. Okay, if you see the system as a distributed system or as a single coherent system, you are working with which of these types? When you are using online banking, how can you see the system? Distributed or single system? Yeah, you see the system as a single system. It likes the application is installed on your personal PC, on your computer. So It is a good example of distributed system too. You don't know where is the servers. You don't know where the data is stored. You don't know how you connect to this network. You don't know any information, the network of this bank. You don't know anything. And the final example is about e-learning. As I said, we are using e-learning now at the moment. You are in Iraq and I am in Iran. We are using Adobe Connect application to connect a server. The server is located on, where is located? We don't know. Maybe in the university, maybe in other location. We don't know exactly where the server is located. We don't know exactly where we is located. I don't know where are you located. So we see this system as a single system. Also, this system contains different independent machines. I'm using my computer, you are using your computer. Different independent machines connected to each other by a network, and we see this system as a single system. So it is a distributed system. Got it? Our operating systems may be different. I am using Microsoft Windows. You may use your Android on your mobile phone. I don't know. But all of us are using this application and we are connected to each other by a network. The network is called Internet. We are using Internet to connect to each other. So we have the network, we have independent computers, and we see the system as a single system. It is a distributed system. Good. I assume you completely got the basic information and important fundamental information about the distributed system. I'm sure that now you know what is in distributed system. In this course, I try to teach you how we can make a distributed system with aspects of software, not hardware. So what we need, what softwares we need to handle and manage these distributed systems, what conditions we need to satisfy and provide, and these are the important parts of the course distributed systems. In other words, we almost focus on distributed operating systems. Can you remember the name of the book I referred to as a reference? What was the name of the book? What was the name of the book? The reference book, I mean. Distributed Systems was the title, and the subtitle Yes, principles and paradigms. This is the main job of us in this course. We will focus on principles and paradigms in distributed systems in this semester. This is our main job. For the next session, I want you to take time and search to find some another examples of a distributed system. Do not only name the title. Give me some short explanation of the examples you will find. Okay, so it's your first exercise. I will give you more details about your assignment in Dersa website, and you will upload your answers on Dersa. So please be careful that you should do your assignment in the given time. In the given time. Delay is not acceptable for me. No reason is accepted. So please be careful about time. I will give you more details in Dersa, okay? Don't worry. I will give you more details about your homework in Dersa, and you will know what you should do. How was this class? Today you had 2 sessions. How was it? Did you find it useful? Is it good to continue in this manner? Do you agree with my teaching style? Give me your comments, please. Your comments can help me, really can help me to improve my teaching. Okay, so at the end of this class, Ziauddin Sahib Ziyareh. Your names are too long, really. It's difficult to pronounce them, and so if I did some mistake in pronouncing your names, please excuse me. It is also difficult for me to find out you are man or woman. Okay. I enabled your microphone. You can speak.
Hi, doctor. How are you?
Hi, thank you. Are you?
I think that you recognize me now. I'm a man or woman.
Yeah.
In fact, doctor, to be honest, at the first time at the class, I saw it's a little bit difficult. A lot of questions, especially for me and for the, we can say, 90% of the student at the class. That's mean we finished the bachelor degree more than 10 years, we can say. So a lot of information that we forgot it, especially for me, for example, I'm working in the analytical and settlement department, we can say. So it's a little bit far from the network and the other. But at the time of the class, in fact, we get a lot of informations and a lot of explanations also. That's for the details that we hear it, but we don't know the main meaning of it. So really, we are glad, and instead of me and in behalf of me and my friends at the class, we thank you a lot for your a lot of explanation that you give it to us and the information. Thank you a lot.
You're welcome. You're welcome. Thank you again. It's my duty to teach you all the things I know. It is my duty. So you can be sure that I make every effort. I make every effort to tell you the fundamental and the important things you should know about distributed systems. So it is a very, very good and also important major in computer area. You can select this area as your interesting research area for your dissertation, for example, if you want. And because I think with improvement in computing machines, as you can guess, we focus and more focus on distributed systems. For example, the application we use are almost distributed. Just look at your mobile phone and see your applications. Most of them are distributed, really. The single applications and the single processor systems area is past. It is the time for distributed systems. And also, real-time distributed systems is another important and interesting area for research. So you can just take it in your memory as a good, interesting research topic as distributed real-time systems. But you need to study more about real-time systems at first, and then go to distributed real-time systems. It's a very good course, I think. It's a very interesting topic in computer systems, and you can continue your research in master and even in PhD on distributed systems. Parallel computing. Parallel computing is also another topic near the distributed systems. Parallel computing, such as supercomputers. Supercomputers are made to calculate heavy computations. For example, computations about weather forecasts, computations about a stock exchange, computations about bioinformatics, and so on. And so parallel computing is very, very related to distributed systems too. It's a very good topic. I'm sure that you will enjoy this course. Don't worry about your final mark. If you follow the course, if you participate in discussions and in the class, if you do your homeworks and assignments well, so I can assure you that you will get a very good mark at the end of this semester. And okay, so you're welcome. If there is no any other questions, we can see each other next week. You're welcome and Khuda Hafiz.